Hello, everyone. Welcome to section 2.5. This section is on linear functions and models. So first off, a linear function is a function of the form. So we have f of x equals and then mx plus b, where here m is the slope, b is our y-intercept. So this is exactly like the equation for a line, just instead of looking at it as an equation, we're going to look at it as a function now. And so we want to use linear functions to model things because linear functions are easy to work with and easy to understand. So modeling with linear functions. So there's three different kinds of setups that we'll see when we're trying to take some real world example and model it with a linear function. So three main setups. The first one is if we have a slope, so like a rate, and a y-intercept, which we can think of as like a starting point for the functions. Wherever we're like starting at time equals 0 or distance equals 0, that's our y-intercept, and our slope is a rate like gallons per minute or miles per hour, that kind of thing. Another kind of setup is if we have our slope and we have a point on a line. So that'll look like, some sort of rate, and then maybe we know like halfway through it hits this much, right? So we've got a point on the line and a slope. And then the third one that we can see is we just have 2 points on the line. So we know what happened at some time and we know what happened at a different time. And so we can kind of connect those 2 dots with a line, with a linear function. So let's see examples of each of these in action. So let's just go in order. So we've got the first one. I'm going to have Jonathan started with 16 cookies and has been eating them. Oops. Let's see, we're going to do 2 cookies a day. All right. We want to find a linear function C of D where C is the number of cookies left and D is the number of days passed. So if I were to actually write this out as a word problem, I'd probably say find a linear function, so i.e. That models how many cookies C Jonathan has after D days. Okay, so Jonathan started with 16 cookies, has been eating them 2 cookies a day. We want to write down a linear function that describes how many cookies Jonathan has left after whatever number of days, right? And so we noticed a couple things about the setup. First of all, we have started with 16 cookies. So we have a started with value. And if you remember from up here, that's going to correspond to a y-intercept, right? Starting value. And then we also have this eating 2 cookies a day. So we have this sort of rate. So that will be our slope when we go down to write this equation. So if we press this, we have, so if we're eating 2 cookies a day, we're going to lose 2 cookies a day. So we're going to write that as a negative number. So we have minus 2 cookies. A day. Okay, so this is our rate. It'll become our slope. And then we also have that at d equals 0, so at the start, we had 16, or not we, but Jonathan had 16 cookies. Okay. So we have our slope, we have our start. And so if we were to write this in, y equals mx plus b terms, our slope would then be m, and then our starting point would be this b right here, right? So that would become y equals negative 2 x plus, and then we're starting with 16 cookies. So we write this in function form. So we want to write a function c with the variable d. And so we would write this as c of d is equal to negative 2 d plus 16. So we can read this as the number of cookies after d days is equal to negative 2 times the number of days plus 16. So this would be our answer. Cool. So this was kind of the first setup that we see here. That was that one right there. We started with the slope, and we had a y-intercept, and we could just quickly write it down. Not much arithmetic involved in that one, which is good. Okay, let's see an example of the second kind. All right, this one's also a lot of writing. So let's see. Jordan works at a bakery. And has been making cupcakes. At a steady rate of 12 cupcakes an hour. Okay, so you're already thinking, oh, we've got a rate 12 cupcakes an hour. This is good. That'll be our slope. That's good thinking. Let's keep going and look at the rest of the setup. So after 4 hours of making cupcakes, Jordan has, actually, let's phrase it this way. The bakery now has 58 cupcakes. Assuming no one, that's a weird E. No one has been eating or making any of the cupcakes. So it's just Jordan just making cupcakes. Nobody's eating them. Nobody's making cupcakes with Jordan. It's just Jordan and cupcakes. We want to write a linear function. Make it C of H, which modeling the number of cupcakes see after H hours? There's also a second follow-up question to this. How many cupcakes did the bakery start the day with? Right, because we don't know that the bakery started with 0 cupcakes, right? They could have had, 8 or 12 or 20 to start with, and Jordan's just been making some and adding to that, right? So we don't know how many they started with, but after we model this with a linear function, we should be able to discover that. So let's look at what we know. So we have this steady rate of 12 cupcakes an hour. So rate of 12 cupcakes an hour. So that'll be our slope. And then we also have that after 4 hours, we now have 58 cupcakes. Okay. So what we have here is a slope and a point. All right. So if we write this down here, our slope is going to be 12 cupcakes an hour. And then our point is that we know that at 4 hours have, what was it, 58? Yeah, 58 cupcakes. So if we write that as a point, that's hour 4, 58 cupcakes. The 4 is coming first in the X slot because the number of hours is our independent variable, and our number of cupcakes is our dependent variable, because however many cupcakes we have depends on what point in the day we're at, right? It's dependent on the time. So 4, the number of hours, the independent variable, is in the X slot, and 58, the number of cupcakes, the dependent variable, is in the Y slot. Okay. So now we have a point, we have a slope. You're like, we should use point slope form. Very, very useful. So if you remember from earlier lectures, that's y minus y1 equals m the slope times x minus x1. And so if we plug in our things, we've got y minus y1 is 58 equals, and then that's 12 cupcakes an hour from our slope, our rate. And x minus an x1 is 4. All right, and then what I'm going to do is I'm going to distribute this 12 into here like this. And so then we get y minus 58 equals 12x, and then 12 times minus 4 is negative 48. And then if we add 58 to both sides to solve for y, we get y equals 12x plus 10. And so here's our slope intercept form of the line. And so now we can just quickly replace y with c of h, and then our x variable becomes our h variable, like that. So this is our linear equation. Excellent. But now we also had that last question where it wanted us to know how many cupcakes did the bakery start the day with. So it's asking about a starting value, which means it's going to be asking about the y-intercept. So all we need to do is just look back up at our equation we wrote down and be like, our y-intercept, our starting value is 10. So the bakery started the day with 10 cupcakes. There we go. Excellent. All right, let's look at our last sort of setup. And if you remember from earlier, that's where we get 2 points from some sort of setup. So Charlie is draining a pool after an hour of draining. Charlie measures how much water is left and sees that they still have 2,700 gallons left. It's a large pool. After 2 hours, Charlie measures 2,400 gallons remaining. So, assuming the relationship is linear, we want to write a linear function. We'll call it g of h, modeling the number of gallons left after h hours. Okay, so if we look at our setup here, we see that we're given that after 1 hour, we have 2,700 gallons, and after 2 hours, we have 2,400 gallons. So we write these out here in compressed form. So 1 hour, we have 2,700 gallons, and then 2 hours, we have 2,400 gallons. And so we want to write these as points. And so our independent variable, our x variable is h, the number of hours, and our dependent variable is g, the number of gallons. So we're going to write these as 1, 2,700, and 2, 2,400. All right, so now we want to be able to construct a line from this. So our first step is to find the slope. And if you remember, our equation for slope is y2 minus y1 over x2 minus x1. And so that gets us 2,400 minus 2,700 all over 2 minus 1, which if you do the math, will get you negative 300 gallons an hour. So now we have our slope, which is good. And now we're going to again use, because we have a slope and we have some points, we're going to use point slope form. And so again, using that equation, we get y minus y1. I'm just going to use the first point because why not? So this becomes y minus 2,700 equals, and then our slope is negative 300, and then x minus x1 is just 1. And then we're going to distribute this negative 300. And so y minus 2,700 equals negative 300x plus 300. And then if we add 2,700 to both sides, we get y equals negative 300x plus 3,000. Excellent. So now we've got a line in slope-intercept form, and now we can just go ahead and write down our linear function. So g of h is going to be negative 300 h plus 3,000. All right. So there is our linear function. Excellent work. So this is how we're going to be looking at setups in the real world. And assuming that relationships are linear, we're going to be able to write down a linear function that describes exactly what happens to whatever we're looking at. So go ahead, keep working on the homework. And if you have any questions about this, I hope to see you in office hours.